Welcome to another coding tutorial, and in today's video I'm going to show you how to create this interactive falling coins to celebrate the Lunar New Year. I was inspired to create this piece after seeing an Instagram reel by Shristi Singh, which combines code from the Coding Train's Falling Sand tutorial with the face tracker that create this super fun and interactive sketch. But since it's the Lunar New Year, I thought that I would switch out the sand for some gold coins, and we're going to be using the machine learning library ml5.js to do the interactive part. So what is falling sand? Falling sand is a simulation that models the behavior of granular materials, in this case sand, as they fall and interact with their environment. It is based on cellular automata, which are computational systems that consist of a grid of cells, each with its own particular finite state. And these states change over time according to simple rules based on the states of its neighboring cells. Now let's talk about how we're going to approach this sketch. Our simulation revolves around two grids, the current grid and the next grid, which represent the current and the future states of each cell. And each cell in the grid can be in one of two states, 0 and non-zero values, which mean they're either empty or they're occupied. And we will initialize the current grid with all cells set to 0. In each frame, we will calculate the next grid based on these simple rules. First, we're going to look if a cell contains a coin or it has a non-zero value, then it will attempt to move down. But it can only move down if 1, the cell below is empty, which means it has a value of 0, then the coin will move there. But then if that cell below is already occupied, we're going to look at the diagonal cells. So we're going to look at the cell below to the right and to the left of that cell. If that is empty, then the coin will slide there. But then if it is not, then no move is possible, and then the coin stays at its current position. And then at the very end, we're going to incorporate the ml5's handPose model to track the index fingers, and that is going to be how we're going to create new coins. Let's start by declaring the current grid. I'm going to call it grid, and it is going to be an array. And then I'm going to declare a few more variables, columns, rows, and size. And I'm actually going to set size to, how about 10? And then inside setup, first I'm going to calculate what columns and rows are going to be, and it is going to be equals to width divided by size, and then rows will be height divided by size. Now we're going to use a nested for loop to create a 2D array. So for let I equals to 0, I less than columns, I plus plus. For let j equals to 0, j less than rows, and then j plus plus. And then to create a 2D array, first in this outer loop, we're going to populate the array with a bunch of empty arrays. And then inside here, grid of I and j. As I mentioned earlier, we're actually going to set these values to 0 as in empty, but I'm actually going to randomize the values for now so that we can visualize it. So how about we set it as random of 2. So this is going to give us values between 0 and 1.99999, but I'm going to also put the function called floor so that it gives us the closest integer. So by this, we're actually going to get value between either 0 or 1. And then now, actually, let me just show you. Let's just print grid. And you can see it's 40 by 40. Is it 40? Yeah, 40 by 40. And it is either a value of 0 or 1. Now, what we want to do next is that we want to actually visualize it. So we're going to do it in draw. So I'm going to also write a nested for loop, the same one. And then we're gonna draw a rectangle. So rect, which takes in a total of 4 arguments. The first 2 are the x and y coordinates of the top left corner of the rectangle, right? So I times size and then j times size, and then the third and the fourth are going to be the size. And let's click run. So now we have a grid of 40 by 40. But then now we're going to write a conditional statement that says if grid of I and j is how about greater than 0, then let's fill it with black, else fill it with white. Ta-da! And as you can see, because of our randomized values that we created earlier, we get a random grid of pixels. Actually, instead of doing this, how about we just draw the rectangle when the values is actually greater than 0. Nice. And I'm also going to do no stroke, and let's set the color to black. Great. Now I'm going to set the values back to 0. And I'm going to write another function called mousePressed to start making it interactive. So function mousePressed, and mousePressed is called every time we press the mouse. We want to create two variables. Let's do let x to be equals to mouse x divided by size, and then let y equals to mouse y divided by size. And I also want to make sure that these returns an integer, so I'm also going to put in floor. Now these values are going to give us the index values that we can actually put in as the index values for the grid. So now we're going to set grid of x and y to be equals to 1. So now wherever we click, then it should actually create a black cell. So let's try it. Nice. All right, how about I change this to mouseDragged? And now we get an error. And that is because when the mouse is greater than the sketch itself, then we get a value of x and y that is no longer is in the cell, right? So what we want to do is that we want to constrain the values of x and y. So how about I say x equals to constrain, and we're going to put in the first argument is x, which is the value that we want to constrain, and we want to constrain it between 0 and cos -1, right? So it will be in between all the index values that are available. And same for y, so y equals to constraint of y, comma 0 and rows -1. And with that, it's all good. Next, let's start by creating those simple rules so that we can get a few falling sands. First, I actually want to put this inside a function. How about we call it drawRect? And then we want to make sure that we put this in here. And then now we're gonna create a new grid, or the next grid. So I'm going to use a nested for loop. Same loop, right? And then we're gonna create a new variable called next grid. And this grid is actually going to be reset every single time the draw loop is called. And basically outside here, we need to populate it with a bunch of empty arrays. And then inside here, we're gonna reset it with the value of 0. Now we want to create the following action using the simple rules that we talked about earlier. We're going to start by creating a nested for loop. So it's the same one. So let me just copy and paste this. And then the very first thing that we need to do is that we need to, how about we create a variable, let's call it state. And this is going to be the state of the current grid. So grid of I and j. So we're going to check if this grid has an empty value or an occupied value. So either one, or either more than 0 or 0. So we're going to check if state is greater than 0, meaning that it is not. So it has something in there. And then we want to check the cell below it, right? But to check the cell below it, we want to make sure that it's not the very last row. So I'm going to write another conditional statement that if j plus 1 is less than rows, then we're going to create a variable called, how about below? And below is going to be grid of I and then j plus 1. And then let's start with the first rule. So if below is empty, right? Then we want to move it down. So we're gonna set next grid of I and then j plus 1 to be equals to state. So basically we're checking the current grid, but we're setting the state in the next grid, right? And then else, then next grid will be next grid I and j, so nothing is moving. So the same position grid of I and j, and then next grid of I and j will be equals to state. And the very last thing that we need to do, which is outside here, we need to set the grid to be equals to next grid. And this is how we will be swapping the current grid and then the next grid over and over again. All right, let's click run. Ta-da! Oh, but then it's fall off the screen. Oh, maybe because I need to set another else statement here. So if it is less than row, we do all of this, and then else, then we set next grid of I and j to also be equals to state. Ta-da! Great. But then now, let's look at this. I'm going to change from mouseDragged to mousePressed again. So it's only falling on top, right? But the rules that we described earlier is such that if there's nothing on the diagonal below cell, then the coin or the sand can slide over. So let's do that. First, I'm going to create a variable called dir for direction, and we're going to set direction to be either 1 or -1. So it will go to the right or to the left. But we're going to do that by doing it randomly. So let's set a random function to as a conditional statement. So if it's less than 0.5, so it has a 50% chance of going to the right or to the left, then we're going to set it to 1, and then else we can do dir equals to -1. All right, and then now what we're going to do is we're going to set another variable called below, how about below diagonal, and it is going to be grid of I plus dir, right? Which dir can either be 1 or -1. So I plus dir can be to the left or to the right. And then j will be j plus 1 because it's the below cell. And then now we need to write a conditional statement that say else if below diagonal is equal to 0, then we're going to set next grid of I plus dir and then j plus 1 to be equals to state. All right, let's see if this is correct. Okay, this works, but it doesn't work if it is the cell that is at the corner, right? Because I plus dir could be negative or more than columns. So now we need to set that boundary. So let's do a conditional statement that says if I plus dir is greater or equal to 0 and I plus dir is less or equals to columns minus 1, I think that's right, then we do this, and I'm going to set the variable outside. So let below diag. Okay, let's try it again. Also, before I click play, let's set this back to mouseDragged so we can see it easier. Run. All right. It works. And then actually, let's set it back one more time to mousePressed so that you can see that when it falls down, it goes to either the right or the left, right? Perfect. So now we have a nice falling sand action. Nice. And by this point, this is very similar to how it is on the coding trains tutorial. So be sure to check that out. Actually, he also make it such that whenever you click or drag the mouse, it doesn't only create one, but it create a matrix of, or like a group of these sand. So check it out to see how he does that. But what I'm going to do is that I'm going to actually first change the transparency or the alpha value of these sand so that it's not all black. So what we're going to do is we're going to change the transparency of this fill here. and we're going to set it to be equals to the value of grid of I and j. But instead of 1 here, we want it to be a value between 0 and 100 because those are the values of the transparency over the brightness. So all we can do is that we want to increment it every time the mouse is being dragged. So I'm actually going to set it to frame count, which gets increment every time, right? Frame count. Let me just print out what frame count is. Print frame count. Yeah, it keeps incrementing even when the mouse is not being pressed, right? It just counts the number of frames. But as you can see here, you can see that it's light gray, darker, and then black, right? Because if I set it to frame count, it just keeps going up, but the maximum value of transparency is 100. So what we want to do is we want it to loop around that. So we can use an expression called modulo, and I'm going to set it to modulo 100. It returns the remainder between a division of two numbers, in this case, frame count and 100. And so it is going to always return a value between 0 and 100, I believe. Let's try it. Oh, and 100. Yes. So 0 to 99, yeah. Now the color looks very light. So I guess transparency also goes from 0 to 255. Let's try that. 255. Yeah, okay. All right, so that's what we're gonna set it to. Frame count mod 255, which gives us a value between 0 to 254. Perfect. And then now, how about we change out the sand for some coins? So inside here, instead of drawing the rectangle, I'm going to draw a coin, and I'm going to fill it with the color that is yellowish, which is this color, and then the last value here, the last argument, is going to be the transparency, which is grid of I and j. And then we're gonna draw an ellipse, and the location, how about we put I times size, j times size, and then size and size. And let's just click run. All right, so you can see that it's a little bit, there's a slight gap from the ellipses and the bottom, right? So for us to really see if the ellipse is inside the grid, I'm going to draw a grid, and I'm actually just gonna copy this. Boop. And I want to draw for all of them, right? So let's put it out here. We do want stroke of black, no fill. All right, you can see that it's not actually inside the grid. So what we want is we actually want to offset it by size divided by 2. All right, so now it is inside the grid. It's kind of hard to see. Let's do no fill. Oh, okay, yes, that's correct. All right, and then I want to now draw rectangles inside, or squares inside these coins. So we're gonna do fill black, and then actually we're gonna do no stroke for both, and we're gonna do rect. Let's do it at I times size, j times size, size, and size. Actually, let's do smaller, size divided by 3. Okay, but then now because of the rectangle mode, it is not in the middle, so we're gonna put rect mode as center instead of the default corner. And we want to make sure that we put rect mode for these as corner so that we still have the same grid. Let's try. Ooh, and then we want to also offset it by size divided by 2, because now it is not at the center. All right. All right, so now we can delete this grid, and we want to, how about also change the background black. All right. Instead of doing it at these colors, starting with 0 to 255 for the transparency, how about we actually set it to be between, let's do frame count up to 205, and then add by 50, so it would range between 50 to 255. All right, so now we have a set of gold coins. Now all we need to do is to incorporate the interactive part by using the ml5 library. So let's start by looking at the website. So we're going to start by clicking get started here, and the model that we're going to use is actually the handPose model. And once you come here, you can scroll down, and this is actually super easy to start with because there are a bunch of examples. As you can see here, there's this handPose example, and I think there's a few more down here. But we're going to start with this one, and all you need to do is open it in p5.js web editor. So just click. And then how about we just click run. Ta-da. Let me move this to the left a bit. You can see that I now can track a bunch of points on my hands and my fingers. We're actually going to be using just the index finger, so this point right here. But let's just look through this example code real quick. So as you can see here, it starts out with a few variables. So there's handPose, there's video, and then there is an array called hands. And there's a preload function where we set the variable handPose to the ml5 model called handPose, and this is how we get the tracking of all the points on our hands. Inside setup here, there is setting up the webcam video by setting it to a function create capture, and create capture actually can capture both video and audio, but if we just put in video as an argument, it just capture the video from the webcam. And we're setting its size to be 640 by 480, and then we hide it. So let's try not hiding it. What happens is that if you don't hide it, below the one up top here, which is on the sketch, there is another video down here, right? But the video that is appearing here is actually based on this image function that draws the webcam video on the size of the canvas. All right, so we're gonna uncomment this. This line of code basically starts the detecting of the hands from the webcam video with two arguments, video, which is the webcam, and then got hands here, which if you come down here, it is a callback function for when handPose outputs data. And as you can see here, it has the hands set to result, which saves the output of the hands variable. And the hands here is actually an array that we declare up top. And then if you come to draw function here, we first drawing the webcam as we looked at it earlier, and then we're drawing all the tracked points from the hand array, right? So we go through the length of the hand arrays. So actually, let's print hand. So just one hand, another hand. And it has, let's see how many points does it have. Has a bunch. Key points are a total of 21. You can also do 3D. It can detect if it's a right hand or a left hand with a confidence level. And then all of these are objects based on where all of these points are. Wow, so these are quite detailed. Perfect. What we're going to use is that we're actually just going to use a point in the key points array here, and actually the index finger is point number 8, index number 8, index fingertip. And yes, so that's how we're going to do it. And I'm basically going to be copy and pasting the code from here to what we have right now. But before we go, we also need to come to index.html, so we cannot forget this. We need to reference the the library. And we can do that by just copying and pasting this source code right here. So let's do that. Then come to index.html. I'm going to put it underneath this line of code. All right, and let's go back to sketch.js.
A few moments later.
Now that we have the two sets of code combined, let's click run. All right, and now we have our tracked fingers. And then if we click the mouse, as we drag the mouse here, we can create a bunch of these coins. But as you can tell, we have not combined these two sets of codes together. But before we do that, I want you to notice that actually the image is not mirroring right now. When I raise up my right hand, it is actually reflected on the left side of the sketch. So I actually want to flip both the model and the webcam before we move forward. And we can do that actually quite easily. So inside the handPose here, how about I declare variable called options and set it to, we put it in a curly bracket, set flipped to be true, and then we're going to put in options as an argument here. Click run again. Then now the model is flipped, but how we display it is not yet flipped. So we're going to do the same thing inside create capture here. The second argument we're going to put in flipped and then true, and then that should do it. All right, so now my hands are mirroring here. So now we want to actually swap out the mouseDragged function and we want to use the index finger. So instead of actually drawing everything here, all the key points, what we want to do is I'm actually going to delete all of this and just do key points at index 8 and just draw that out. Click run. All right, and then now we get the index fingers, right? But instead of just drawing out these index fingers, we're going to swap out the mousePressed function, the interactivity there, with our index. So what we want to do is go down to the mouseDragged function here. How about we change it to add coins and give X and Y. Actually, let's do finger X and finger Y as the arguments. And we're going to swap out the mouse X and mouse Y here to be finger X and finger Y parameters. And then up top here, instead of just drawing out circles, we're going to be calling add coins at key point. Actually, let's not do key point. Let's call it finger, index finger. So it's going to be index finger.x, index finger.y, and we don't need the size here. And I think this should work. All right. And then now we're creating a bunch of coins with our index fingers to celebrate the Lunar New Year. So this is a super, super fun interactive sketch that is a combination of a bunch of basic concepts. So I hope that you like it, and happy Lunar New Year to anyone who celebrates, and give this one a try.